Hello everyone. So today we'll discuss the final experiment in the design laboratory where you calculate the fringe constant using a photoelastic method. So photoelastic method principally belongs to such category of materials where you can use a material which where the light can pass through. So such materials are used for the various stress analysis purpose. So we will see how it goes on. So the aim of the experiment is to determine the fringe constant using the photoelastic material. Using a circular disc is subjected to a diametrical compression. So only this is available for you. Okay, pure bending, which is the 4-point bending, which is not there for you. So only one this, which is the circular disc, which is subjected to a diametrical compression. That means there will be a circular disc where it is subjected to a diametrical compression like this. The load will be applied by means of a hydraulic system. We shall see how the things goes here. So the model, if you look at the model, it will be something like this. So this is the model here. Okay, in this particular model, the eye of an observer will be here, and the monochromatic light source would be here. Okay, so the first plate which we observe is through the analyzer, after which you get a quarter wave plate. After that, in the between there will be a model like this. After that, again a quarter wave plate which is 45 degree tilted. Okay, this is 45 and this is 45 degree. This is 0 degree and 0 degree. Okay, so analyzer is of 90 degree. So you can observe it. So polarizer is of 90 degree and analyzer is of 0 degree. So just maintain all this using certain dials over there. So practically you can observe like this. This is the way where the load is being applied. So your optical disc is being placed here. The load is being applied hydraulically. We shall see such arrangements how the load is being applied. So as soon as you give the load here, it would be subjected to a diametrical compression like this. Okay, let us see the experimental setup. So this is how an experimental setup look likes. Okay. Okay, so this is the monochromatic source. You can observe here the monochromatic source is there. So exactly up next to it there is a polarizer. After polarizer there is a quarter wave plate. So there are two different discs here. Okay, and here is the thing where you place the model. So circular disc will be placed exactly here, after which again a quarter wave plate and an analyzer. So all the setup would be there. You have to weave from this particular point. Okay, all the fringes and all. So this is the hydraulic system which I was talking about, where you use to apply the load onto a diametrical photoelastic specimen. Okay, the diameter of the disc is 70 mm, just noted, and thickness of which is 9.7 mm. You can use the vernier to just calculate the things up. Okay, now how to perform this experiment? Let us look into some of the videos now. Okay, so this is how it would be. You can see the diametrical disc is being placed center, and this is the knob by which you just apply the load using a hydraulic arrangement. So once you apply the load, when you look into the analyzer like this, the fringes are observed. The black color shades you can observe. See, one fringe. Now this is a second order fringe. Two black color shades. Now this is a third order fringe. Three black color shades. So all this you can observe. So correspondingly, for that particular value, what will be the load taken? You have to just look into this particular reading here, so which gives you the load taken. That has to be noted down. So that is the reading what you get here. Okay, for first order fringe or second order fringe and third order fringe, what is the load on the material? So that you will be noting it as 48, 86 and 126, as you have just seen now. So using this, using the formula F sigma 1 is equals to 8p divided by pi dn, just substitute the things for all the three different readings, that is for 1, second and third reading. Substitute the value of p, which is the load, d is the diameter of the circular disc, n is the fringe order. So just substitute the things up, you will be correspondingly getting F sigma 1, F sigma 2 and F sigma 3. Take average of these three values to get the average value of F sigma, which is known as a fringe constant and a material fringe value. Both mean the same thing. So by calculating the material fringe value 15.81 Newton per mm, your experimentation is done. So this is how you calculate the material fringe value using the photoelastic principles.